Welcome to our presentation. This is the Group 12 presentation on digital forensics. The group consists of Tim, Michael, and Daniel. We will be talking about SSDs, and we have called this presentation The Inner Workings of the New Storage King. SSD, which stands for Solid State Drive, has greatly improved the way to store data. Factors such as reliability and speeds of transfer when reading or writing have greatly been improved. This allows for increasing performance in an older computer, as the hard drive can be replaced with an SSD to increase the speed. Although SSDs are fast compared to hard drives, they may not be as cost-effective as hard drives offer a bigger storage capacity for less or has a better cost per megabyte ratio. Due to the benefits of the SSD, it has become the industry standard for most consumer and professional hardware, meaning that this increases the challenges of a digital forensic investigation as more and more computers use it as a preferred way of data storage. There has been a shift in technology used in storage. Although the SSD has the same functionality as the hard drive in which it stores data, many of the functionality have different processes. For example, when deleting, erasing, writing, or formatting. There are processes in the background of an SSD that differ to the way hard drives manage data. These processes enable the SSD to completely delete blocks of data after a few minutes of being marked for deletion. Other processes, which include optimization techniques, may lead to data recovery issues that make it so that data can't be recovered. During a digital forensic investigation, the way the SSD functions caused the investigators to face a lot of challenges. SSDs are not all made the same way. They are made by various manufacturers using various different methods or standards in achieving a usable SSD drive. This presents the issue that there can't be a one-fit-for-all solution, and some SSDs may have to be dealt with differently to others in order to recover data. There may be variation in the results obtained by recovering SSDs made by different manufacturers. There also, however, may be exploits known to the manufacturer that may aid investigators in recovering data of a specific type of SSD. Digital forensic investigations carried out on hard drives are easier to investigate. This is because when files are deleted on a hard drive, it's not completely erased. However, it's marked as space to be overwritten on. Full recovery of data is therefore possible. If the old data hasn't been overwritten on, investigators can then look at sectors within a cluster and then find and recover information to be used as evidence. Data could also be partly recovered, as there could be parts of the old data that hasn't been written over yet in some clusters. These bits of information may provide some evidence to support their investigation. According to the study by Vieira et al. In 2018, SSD data could still be recovered after deletion. The study found that the results may vary depending on the manufacturer, and the use of trim in SSDs reduced the amount of data recovered by a great amount. It was also found that even though the translation layer may change, the data that is shown to the operating system does not change. Extraction tools must be able to communicate with the storage device for it to recover any data. Unfortunately, doing this will cause there to be a small amount of change in the data. This, as a result, then interferes with the validity and or integrity of the data as it's been altered. Another case study by Griers in 2015 showed that the copies of the SSD data that were hashed changed after 3 hours of idle time. The study proved that the background processes in the SSD made it harder to maintain the integrity of the evidence found.
Read, write, and erase. Data in SSDs are written in pages, which are organized into blocks. Blocks are organized into a plane, and planes are organized into a die. Reading and writing data in SSD is done on page level. However, erasing any data is done at the larger block level. Now, why is that? Let's recap. A memory cell stores a charge, and its presence or absence determines which are ones and which are zeros. A charged cell means 0, and a cell without a charge means 1. Erasing means charging the cell. The NAND flash is subjected to a higher voltage when erasing than writing on it. The higher voltage could damage the memory cell at the page level. To avoid damaging the cell, data erasure has to happen at the block level. This means that by simply updating a data in a page, the data in the entire block is copied into memory, written into a new block, including any changes. Then the old block is marked dirty and will be processed by the garbage collector. Garbage collection and wear leveling. Garbage collection is an automatic background process. It ensures that there are as many empty blocks as possible. The garbage collection process scans for stale or dirty pages, consolidates all the useful pages, and copies them into new or empty blocks. The old blocks containing the stale and dirty pages are then completely erased, empty and ready to be used again. New blocks or blocks with the fewest write cycles are used because flash chips have a set amount of write operations before wearing off. The ideal wear leveling scenario is that the chips wear at the same rate, increasing the overall lifespan of the SSD. Over provisioning. SSD tends to slow down once it starts to use up its capacity. To increase its performance and lifespan, manufacturers set a certain percentage of the capacity in an inaddressable part of the SSD. This is called over-provisioning. Yes, SSD can, in some cases, hold considerably more data than advertised. Have you ever wondered why some SSDs are sold with a weird capacity, such as 240 gigabyte and not the usual 256 gigabyte? Or when you do buy an SSD with a familiar sizing, let's say 512 gigabyte, the actual capacity when inspected is much lower. The missing or extra space exists in the SSD, but it is not accessible to the operating system, nor by any ordinary means. A digital forensic investigator would need specialized skill, software, and equipment to access the data and recover any useful evidence hiding behind the over-provisioned space. It is also important to note that different manufacturers allocates different percentage of the over-provisioned space in the SSDs they make, with the percentage moving between 7% and 28%. The bigger the percentage, the better the performance and lifespan of the SSD. Users can even allocate their own over-provisioning just by not allocating all the SSD free space into a formatted partition. Cannot erase. The process of over-provisioning combined with wear leveling will leave blocks that may contain sensitive information scattered anywhere within the memory chip, including the inaddressable part. Information stored in SSD can be quite difficult to remove. The wiping process must be done at the hardware level to ensure that the data has been securely wiped. This property can be useful in recovering information or any evidence which has not been erased or has been subjected to the trim command. Cannot recover. On the other hand, it can be very difficult to retrieve files that were marked for deletion, unlike hard disk drives, where overwriting data may create slack space and deleting data does not really erase any information and only marks the space as writable. SSD uses its garbage collection to permanently erase, mark for deletion, dirty, deleted files, and modified data automatically. This could even happen when evidence is being recovered. In cases where data had already been recovered, the data may not be fit for or usable as evidence as it may appear to have been tampered with. Furthermore, blocks of data processed by the garbage collector are physically erased and impossible to recover. It is gone forever. Forensic researchers refer to this process as self-corrosion. Take note that the garbage collection will happen automatically. However, it does not happen instantaneously after the trim command has been issued. This is because the trim command only adds the dirty blocks to the queue which the garbage collector has to deal with when it got the free time to do so, which could happen anytime and would be very difficult to stop.
Trim is the command issued by the OS to the SSD controller, allowing it to identify which data blocks are no longer needed and can be erased by the garbage collector. Now, once the trim command has been issued, it's very difficult to stop the garbage collector. The chance of recovering data before the trim command is issued is high, and unlike the garbage collector, the trim can be disabled. Now, the Corsair User's Guide explains that this trim is designed to keep the SSD at its optimal level to maintain its performance. It is possible that the trim is not supported by the SSD, so we can still recover, for example, from external drives, and there are instances where it's not supported by the OS in any way. Physically disconnecting the built-in garbage controller is possible, where your chance of then recovering data increases. But that method requires specialist skills and specific hardware to read the information directly from the flash chip. An approach for analysing SSD called chip-off analysis is the labour-intensive process involving taking the NAND chips from the PCM board and analysing them separately. It's estimated that chip-off analysis of a 4-chip SSD would take around 2 weeks, and a 10-chip is almost impossible to process using our current methods. Yeah, we have been warned this can't be applied to data blocks that have already undergone garbage collection, because they've already been through the process known as self-corrosion, and that information cannot be recovered because it has been physically erased. Another strategy that can be employed to recover data is simply asking the manufacturer for help. Manufacturers can use factory access mode feature of SSDs to execute low-level commands which the SSD simply can't perform in standard mode. With factory access mode, your digital forensic investigator can access several features such as reading raw data from the physical blocks, not dissimilar to the chip-off analysis, only without having to pull in the chips. The downside is that even if the media encryption key is not encrypted, encrypted data cannot be decrypted. However, factory access mode has a different feature. It allows you reading the logical data blocks, which will overcome the encryption if the MEK has been used. Another bonus is that the over-provisioned blocks and trim blocks which have not been physically erased can still be recovered. Several other features using factory access for digital forensic investigators is the ability to disable the SSD controller's background process. This has got two main features. We can stop the garbage collection, the wear leveling and address remapping process, which can save us from accidental destruction of evidence. It also gives us a chance to access the ordinarily inaccessible part of the SSD, like the over-provisioning area, which may contain a recently deleted file. A comparison between SSD and HDD still shows us that the HD is still cheaper, it's still more cost efficient, it still has greater capacity. The reason SSD is overtaking HD is because it's quicker, it's much faster. So the golden days of slack space, file carving from the HDD are almost at an end, because your SSD is dominating as the new storage king because of that speed. SSDs require digital forensic experts to develop new approaches and new techniques that allow new extracted information to be used as evidence. Covering solid state drives and their implication in the use of digital forensics, we need to move forward into the realm of SSD. Digital forensic investigators might have to recover evidence from SSDs that have been destroyed, had their memory deleted, or have broken down. And you can ask, how do we recover the data from the SSD and use it as evidence in court? Well, the only one true course of action is that we're not particularly sure which course of action to take. It does depend. It's almost impossible to recover physically erased data, but in other cases we can recover evidence from SSDs using the correct acquisition techniques. Be it chip off, broken pins, partially erased, there are numerous exceptions which prevent background processes from destroying evidence through self-corrosion. SSD data recovery depends completely on the individual circumstances and the right course of action taken by the digital forensic investigators. Thank you. Our references can be seen on this and the subsequent slide. Thank you very much.